Today we will be working with cylinders. You see here we have a cylinder drawn, and it consists of two parallel bases made of circles connected by one side, which is itself what we would call cylindrical in shape. Now the parts of a cylinder are very similar to the parts of a prism. You have two bases and a lateral side. So the axis is the line which connects the midpoints of the two bases. Another definition which will be important for this chapter is that of a right circular cylinder. A right cylinder is a cylinder in which the midpoints, the line connecting the midpoints of the two bases is perpendicular to each base. And a circular cylinder is a cylinder in which the two bases are both circles. For the most part in this chapter, we will be dealing with right circular cylinders or circular cylinders, in which the bases are both circles, but the line connecting the midpoints is not perpendicular to the bases. And we'll see examples of this later. For now, though, let's also be aware that we need to work with cube roots in this chapter. And a cube root is very much like a square root, but we will explain it in more detail when we get to problem 15.3. Today's image is Le Bassin des Jeux de Bouffan by Paul Cézanne, an impressionist painting from 1876. This pond is from the outskirts of Provence in southern France and was painted by Paul Cézanne outdoors on this beautiful villa in the countryside. Alright, so let's move to problem 15.1. Suppose we take the cross-section of a cylinder that is perpendicular to the axis of the cylinder. What is the shape of this cross-section? So we're taking a cross-section, and by a cross-section you can think of a plane. So we're going to take a plane on our cylinder, and it's going to be perpendicular to the axis of the cylinder. So let me adjust this plane. And it's perpendicular to the axis, meaning that this is a right angle. What's the question? What is the shape of this cross-section? So what shape would be imprinted on this plane from our three-dimensional shape that's passing through it? I'll give you a moment to guess. It is another circle. Alright, let's try another one. What is the shape of the cross-section of a cylinder that contains the axis of the cylinder? So now we're going to imagine a plane that cuts through the axis of the cylinder. In this case, which shape will be inscribed on our plane by our cylinder? That one will be a rectangle. What is the shape of a cross-section of a cylinder that is parallel to the axis of the cylinder? In this case, we'll just be moving the plane away from the axis, and I'll ask what this new cross-section is. So this plane is parallel to the axis of the cylinder, and this part of the cylinder that it contains is still a rectangle, but it's a smaller rectangle, because the greatest extent of the rectangle, its greatest width is its diameter, and all of these other chords will be smaller. Alright, let's work with 15.2 now. Here we have our cylinder with base O and base O prime. Here we have our cylinder with centers O and center O prime. It's worth remembering that this symbol means prime, and we use O and O prime as opposed to, let's say, O and P, because prime lets us know that these have a relationship. O and O prime have the relationship of being identical midpoints on identical circles. And so using the prime notation emphasizes that for us. So this figure has a radius of 3 and a height of 5. So which of these lines is the radius? Is it from O to X or from O to O prime? O to X is the radius, and it's 3. And O to O prime is 5. Find the volume of the cylinder. Ooh. We have not been told how to find the volume of a cylinder yet, but we can still use our rule from the volume of a prism. The area of the base times the height. What's the area of one of these bases? Well, they're what shape? They're circles. So the area of the circle is pi r squared, and so we will have pi r squared times the height. And what is our height? It is 5, and what is our r? It is 3. Suppose we cut the surface of the cylinder along the dotted line and unroll the surface onto a plane. What type of figure results? One way to think about this, unrolling, is to consider a different type of roll, very popular in today's society, the toilet paper roll, and consider what type of shape emerges from this mysterious object. As you can see, I've already have an unrolled shape here, and an unrolled cylinder has a rectangular shape. Now, having a rectangular shape makes it very easy for us to find the lateral surface area. We know that the height of our rectangle is 5, and the length is the same as the circumference of the circle. So the length is 2r pi. So the lateral surface area equals 5 times 2r pi, 30 pi. And now we just need the total surface area of the cylinder. And the total surface area is the lateral surface area plus both bases. It will be 30 pi plus 2 times pi r squared, because pi r squared is the area of one base. And what do you get when you reduce that down? $30 pi plus 18 pi, 48 pi. And now that we've done this for an example right circular cylinder, we can create the formula for the volume, lateral surface area, and total surface area of a cylinder with a radius r and a height of h. And now we can figure out our entire formula. So in this case, the volume is pi r squared times height. The lateral surface area, and the lateral surface area is pi times the diameter times the height. And the total surface area is the lateral surface area plus both bases. So that is pi dh plus 2 pi r squared. Excellent job. Okay, let's move on to our last problem. And in this problem, we're going to have to take a cubed root. And so I want to introduce you to the cubed root first, how to work this out. So what's the square root symbol? It's this one. And the implication in the square root symbol is that there's a little 2 right here, letting you know that it's square root. The cube root has the implication of a little 3. Just as squaring undoes the square root, and a square root undoes a squared variable, so too does the cube root undo a cubed variable, and a variable cubed undoes a cube root. So let's look at an example. If I wanted the cube root of 8, I would factor 8, and I'd look for 3 of a kind as opposed to 2 of a kind in order to spring out of the square root jail, out of this radical jail, if you will. So 8 is made of 3 2's, and so the cube root of 8 is 2. Those 3 2's can spring out. Let's take the cube root of 16. Sixteen is made of 4 2's. 2 times 2 times 2 times 2. If I want the cube root, remember I need the cube symbol here, or the little 3. I have my 3 of a kind, but one of my 2's has to remain. And so I will wind up with 2 cube root of 2. And that's how cubed roots work. As we've discussed before, you need a buddy to break out of jail. You need a pair to get out of a square root. For a cube root, you need 3 of a kind to get out. Alright, with that said, let's begin this problem. In 15.3, the radius of a cylinder is 2/3 its height. Find the total surface area of the cylinder if its volume is 96 pi. So let's look at these 2 facts we have. We know what the volume is, so we're definitely going to be reverse engineering the volume. And we know that the radius has a certain proportion to the height. So let's write both these facts down. The radius is 2/3 the height. And this means that throughout all of our problem, we can replace r with 2/3 h. And we also know that the volume is 96 pi. Let's see if we can use this fact to discover what h is. What's the formula for the volume of a cylinder again? Don't look, see if you can remember, or reason it out. the volume equals pi r squared times height. And we know that r, in this case, is 2/3 h. So the volume, 2/3 h, squared times h. 96 pi. Now we can reduce this problem down and figure out what h is. And you might be intimidated by it because we have a 2/3 h that's squared, and I know that's intimidating for many algebra students. And we are going to have to be doing some work with fractions and exponents. So we'll break this problem down. We'll square each thing one at a time. What is 2 squared? It is 4. 3 squared? 9. H squared? H. We're going to multiply, and then we have another h in here. And this makes our life much easier. 4 over 9, 4h cubed over 9 times pi equals 96 pi. Now we can move our pi to the other side by dividing both sides by pi. Oh, that cancels the pi's out. We can get rid of our 9 by multiplying by 9. Ooh, what's that going to equal? Quick, to your calculators, friends. So we have 864 equals 4h cubed. And then we can get rid of our 4 by dividing by 4. We'll wind up with 216 equals h cubed. And now we have to undo the cubing. So we're going to take the cube root of both sides. And I do want you to get this, so work it out with me or try to work it on your own in advanced. Okay, let's reduce this by dividing it by 4. I think that's the obvious thing to divide by. That's probably what you will divide by. So you get 4, 54. Now let's divide our 54 up. Well, that's 9 and 6. We can divide our 9 up, 3, 3. Our 4 up, 2, and 2. Yeah, it's okay. Our 4 up into 2, and 2. And our 6 up to 2, and 3. You'll notice that we have 3 of a kind on 2s and 3 of a kind on 3s. So we'll pull both of them out and multiply them by each other. H equals 2 times 3. H equals 6. Alright, so we found our H. And all that's left to do now is find the total surface area of the cylinder. We know what H is, and that means we can find R. R, as you recall, is 2/3 of 6, 2/3 of H. So R equals 4. Now we want to find the total surface area. What was that equation again? The lateral surface area plus 2 times our 2 circles. The lateral surface area is 2 times diameter The lateral surface area is diameter pi times height, and our two circles, our two bases, are 2 times pi r squared. What's the diameter? It is 8. What is our height? It is 6. 8 pi 6 plus 2 pi 16. Yes, 4 times 4 is 16. 32 pi on the one hand, plus 48 pi. And we have our solution. 48 plus 32, 80 pi. And that solves all of our problems for the core concepts of working with cylinders. The problem set in this section includes extending just these few facts that we've gone over into working with different types of cylinders. But none of them will depart too far from all of the rules that attain for a right circular cylinder. Thank you very much. You have a wonderful day.